Hello everyone, thank you very much for joining Sushi Tech Tokyo 2026 today. Now we begin the session on Can Japan's physical AI lead again? Japan is back in robotics. So please welcome our speakers. Microsoft Japan, Hiromichi Nozaki. Preferred Networks, Hamzawi Karim. Now, the floor is yours. Please.
Hi everyone, how is it going? I am very excited to host two leaders here from Microsoft and also Preferred Networks. So let's begin with the introduction. So could you please start, Karim-san?
Thank you very much. Hi, everyone. Thank you to Sushi Tech for having us and to Microsoft for hosting us in this session. I'm very looking forward to discussing the topic today. My name is Karim Hamzawi. I'm from Preferred Networks. I have spent the last 20 years in the deep tech ecosystem. I started my career as a software engineer and gradually moved to the business side. So I'm in the exciting intersection between technology and how that is used in the industry in Japan. So I'm very looking forward to talking to you about some of those topics.
Wonderful.
So Preferred Networks, maybe not everyone know about us, but we are a deep tech company based here in Tokyo. We have been doing AI for the last 12 years, focusing both on building the AI stack from AI solutions all the way down to the semiconductor. And we have been working very closely with our customer to diffuse AI across industries, so automotive, manufacturing, drug discovery. So we have been fortunate to see how Japan has been adopting AI in the industry, and I'm looking forward to talk to you about that. Recently, with the emergence of generative AI, there is a new layer in the technology stack, which is these foundation models. We do develop our own called PLaMo. So it's a Japan-made model that is now starting to power a lot of the applications for our customers. So we're happy to talk. Probably that would be one of the focus of our session today. Thank you for having us.
Yeah, thank you so much. So Nozaki-san, could you please introduce yourself?
Hello, everybody. My name is Hiromichi Nozaki. Thank you for having me to this session. I appreciate that, Karim-san, too. So I'm Microsoft CTO in Japan, and then my career began the software engineering first. And then a few years later, I moved to the database company, and then having a database and engineering experiences. And after that, I moved to the Silicon Valley and working at the headquarters in one of the megatech company. Then 20 decades, I think I worked in this company. Then moved to the startup to work on the fintech application development as a global vice president of engineering. I led the teams. Then after that, its long journey was ended, and 25 years later, then I moved back to Japan. And this is the third year in the Japan Microsoft. So today I'm very excited to discuss how we are bridging Japan-built innovation with global scale platforms.
Perfect, thank you. So Nozaki-san, could you please introduce your company Microsoft approach to the LLM implementation?
Sure. So I like to take a moment to explain about the Microsoft Foundry, which is our the tools for AI development platform. That we offer secure and then scalable LLM implementation platforms via Microsoft Foundry, which provides a unified platform deploying over 11,000 foundation models. Then actually this includes a lot of mega famous modules like Azure, OpenAI, and the cloud, and then even DeepSeek. A lot of famous models got available in the OpenAI data sources too. The third-party industry-specific models from partners like and the other tools available too. So all the models operate under the same API interface, and more importantly, under the same high standard of security, compliance, and governance. So today we are very thrilled to announce that the PLaMo is coming to Azure. This represents the perfect integration of preferred networks, the domestic expertise, and the Microsoft global scalability on the same platform.
Wow, that is very wonderful announcement. Thank you so much. So let us move on to the next section, why preferred networks and Microsoft. So Karima-san, could you tell me why you chose Microsoft as your cloud platform partner?
Yes, with a pleasure. Thank you for having us on Azure. We're very excited about the partnership and looking forward to provide our PLaMo models to a wider industry here in Japan and globally in the future. So to frame things a little bit, I will talk about, when we talk about AI, there is what you're providing to your customer and how you're providing that. So I'll talk about the what. So our company spent the last 3 years building these generative AI models that are built from scratch. So we have control over the data that goes into the model, the capabilities that we are prioritizing. So this model is considering Japanese and Japan as a first-class citizen. So from the development, we have that as the first priority for our models to be able to provide the highest quality for our customers here in Japan. So we have been doing that throughout many cycles. I think that we are in the 3rd generation of our models, and we have been fortunate that it was received very positively in the market. We have been fortunate to be awarded many rewards across that journey. And I can put slides with many, many benchmarks, but probably you're bored of those continually evolving benchmarks. But I will pick just one, which is the instruction following benchmark. So this is how your model can actually follow what you're telling it to do. This is the most frustrating part when you're talking to models. If they're not really answering your questions and your queries, it requires you doing that frequently to be able to achieve your goals. So this benchmark is, I prefer this one over the others. So we were able to have the most capable model comparing to the existing open source and the Chinese models as well. So that's what we've been building so far. Maybe to go to the next slide, please. So the first thing when you're building a model, the critical part is the data. So have spent a lot of time building high quality data, Japanese data. That means Japanese language and also Japanese knowledge in the model. So this is a comparison between an example of frontier models. It could be a llama, it could be other things. Usually the Japanese portion of data is just a few percent of the overall data. For our models, it's more than 50%. So we make sure that our model can grasp as much information about Japan, about the language and its nuances, and that's what increases the quality of our model. Next. So by doing that, we have very wide range of happy customers. So we have been providing this as an API, but also embedding our model into other platforms, be it in SBI or PLaMo or MC Digital. So we have many partners across the industry that are providing our model to their customers. And there are also a type or a segment of customers who want to add more knowledge in the model, or they want very specific, specialized models. So we build sometimes finance dedicated model, agriculture sometimes, and we also have a model that is specific for translation, which was also very positively received by the user. So it has very high quality translation between Japanese and English. So that was a very great journey for us to see our model being adopted across the industry. Recently, one of the highlights was that it was the first Japanese model that was adopted by the government. So this is one of the highly sophisticated and critical kind of requirements, and our model was able to satisfy the requirements from the government, and now it's being used by across municipalities. So that's on the left side, that what we achieved last year. On the right side, just a translation, which you can go ahead and use it for free on a browser to give you a sense of how our model can give you very fluent and easy to understand Japanese. So that's what we are providing, and we have been in this journey where we are bringing other consumers and industry with us. But once you want to provide it to very sensitive and critical, mission critical use cases, be it in finance, be it in healthcare, then you need not only the model, but you need to make sure that the security and data governance and those kind of things are well secured. And that was the biggest motivation for us to partner with Microsoft, that they have a great platform that takes care of that. I think Mozaki-san will share more details about that platform, but that was the main reason for us. Thank you for asking.
All right. Shall I? So for enterprise adoption, not only the performance of LLM, but also non-functional requirements like data residency and network isolation are necessarily needed. So I think nowadays, I think even this session we are talking about it, more about the data residency requirement was a heavy requirement, actually, the very important requirement for the Asia and Japan particularly, for sure. So the Microsoft, the MaaS called like the Master as a Services architecture support managed the VNets and then private links, ensuring that inference data never traverses the public internet, which is most important for many customers concerned areas. The identity is handled via Microsoft Entra ID, providing granular role-based access control for every model and agent. So we also support AI gateway for rate limiting, capacity management, and the optional routing across multiple models, and the security. So I'm particularly talking about the security in the next slides. So we are offering LLM-specific security. The Microsoft Foundation, Foundry, as I said, this is a development tool for AI that which Microsoft offers. And then this Microsoft Foundry includes a prompt shielding to prevent the prompt injection attacks and the multimodal filtering to ensure the safe content and generation across the text and images. So furthermore, Microsoft Defender, which is my favorite product, for AI provides continuous threat detections. So integration with Microsoft Purview allows for automated data classification and then governances. That's the most strengths for this Foundry plus security combinations.
Thank you so much. Now we understood how our functional and also non-functional requirements are met by this new collaboration between Preferred Networks PLaMo and Microsoft Foundry. So we understood the technical requirements. So let us move on to the industry use cases. So Karimi-san, could you tell us more about your industry use cases and strategies?
Yeah, thank you. But before going to that section, maybe I want to add one more comment. With all the functionalities you have, there is something that was a big motivation for us as well, is that you have happy customers that asked us to bring PLaMo to Azure. So they have their applications on top of Azure, and they want to combine with our PLaMo. So that was also a big driver. So I think it's a very positive thing that you should be very happy with your platform. Thank you very much. Now I can explain a little bit on some of the applications that our customers are using, starting from the government. So we collaborate with PLaMo, that is providing Commons AI to the municipalities across Japan. So this is more than 160. I think the number is growing quite fast in the last few months. So basically, it's being used in municipalities that are either handling a lot of inquiries from their citizens or handling very complex and complicated documents that are in Japanese. So that is one of the applications that we have seen to go very quickly as adopted across the industry. And our PLaMo is integrated there to provide both that Japanese capability and also Japanese know-how. Can we go to the next one? These are some of the comments from our customers or from the prefectures. So they are the first thing or the first feedback is that they mentioned that our Japanese is very fluent, is very natural. They were also happy with the compliance with the Japanese law and ethics. And I think that the main reason why it grew very quickly is that they already saw significant improvement in their operation efficiency, and that's one of the biggest driver in adoption across the industry that we see. Some use cases, for example, PLaMo is able to provide you more information about Japan. So for example, if you are a tourist that come to Tokyo and you want to ask which places you want to go to, they notice that PLaMo can give you a more detailed suggestion on where to go. So I think our model was able to capture a lot of the know-how about not only the language but also Japanese specific characteristic. Then maybe go into another use case. So when you are dealing with a very a highly regulated, highly sophisticated with high stakes operations, like for example the financial industry, you want to build, for example, a system that will enable you to retrieve information across documents in your organization. The biggest challenge is that a lot of the know-how that the employees are operating based on is very tacit. So it's not well documented or it's not explicit. So it makes it very difficult for LLM models to be able to capture that nuance and expert thinking. So the system down here, this is a very typical way of designing a system. So you have a lot of documents on the back end, and you make your generative AI kind of make that easy to search. So you build a structure based on Gen AI, and then you have an agent that goes back and forth to bring you that relevant information. So here there are some of the pitfalls or the difficulties if your model cannot really build a highly sophisticated structure. So you build a structure with the back-end know-how that this is more suitable for finance or more suitable for healthcare. That is a key component in making very highly sophisticated systems. And then you need also your models to be able to understand your instructions. So if your instructions is in Japanese, you want a model that is able to capture that in a very high quality. For example, I switch from languages when I talk to models, either GPT or PLaMo or others. If you ask a question in Japanese, sometimes you get a quality that is less than if you ask it in English. So that is very frustrated to users, and you want your models that if the end user is Japanese, you want the model to capture that request in most accurate way possible. So those are two key points that kind of make a big difference when building models for Japanese contexts. So I think, yeah, those are the two use cases that I brought.
Oh, thank you so much. The finance use cases were really wonderful. And many of you have heard the word agentic when you talk about the use cases for LLM. So Nozaki-san, could you tell us how Microsoft is accelerating those agentic use cases by Microsoft Copilot and other your platforms?
Sure. So now the world is agentic AI. Then people are very easy to create agent by just sending the prompt without coding. Now the backend agent is created. So you can, for example, schedule something by typing prompt, and then as a backend, then agent is automatically created. Then now, very interestingly, the capability of creating agent comes first, earlier than the managing the agent. So what happened now is that we need a tool to manage the agent. So this is the Microsoft will provide the agent, the product called Agent 365. So these tools allows to monitor and manage and all the agent, whatever they created within the networking in the Microsoft tenant. So that's the tool. So we can create agent by Microsoft 365 or any third-party tools. We can create it within the Azure services. Then Agent 365 is a capability, having a capability of and managing, monitor, and then delete, create new, that kind of stuff. We can do this from these tools. So now we are introducing Agent 365, then centralized control plane. Like we call it centralized control plane for managed identity, and observability, and then interoperability for all the agents. So then I repeat through the Agent 365. So PLaMo can be integrated in the Microsoft 365 ecosystem as well. So driving into the massive data onto the 365 and the Azure. So this allows Japanese enterprise to process their proprietary 365, M365 data using PLaMo-based agent as well. So all within the secure, the governed environment, we could achieve this end-to-end consolidated environment Azure on Agent 365.
Thank you so much. Oh, that's so wonderful when how PLaMo's agent and Microsoft 365 Copilot is connected via Agent 365. That is very good use case. Thank you. So moving forward, physical AI is quite hot topic for many frontier model providers, right? So Nozaki-san, as frontier model provider, could you please tell us how Microsoft approaches the world of physical AI?
Yeah, it's a really big topic, the physical AI now, because of looking at the agentic world in Japan physically, because a lot of older people then requires some support from human being, then also the high demand for the robot. Then, so that's kind of like a situation that Japan is facing compared to the other countries. So bringing AI to the real world, this is the physical AI. And it's quite hot topic, right? And especially for manufacturing, healthcare, and then nursing care. As I said, it's really the big topic for nursing care specifically. So whether it's a plant automation or robotics, the real-time multimodal processing is a key success factor.
Oh, thank you so much. Karim-san, could you please introduce preferred networks approach as well?
Yeah, thank you. Indeed, the physical AI is a hot topic that we hear more often about these days. From our company's perspective, one of the main motivations why we started the company in the first place in 2014 is to bring AI to the key industries in Japan. So while AI was being used in social networks, in search engine optimization, we thought that there is a huge potential for AI to also help the physical world. So that be it manufacturing, it could be automotive, oil and gas. So there is a lot of applications or industries in the society that also should benefit from AI. So since 2014, we have been working on bringing AI to the physical world. So now it's being called physical AI, and people are imagining humanoids and robots, but actually it's a much wider space. And there the challenge is how can you scope a very useful use case in the real world that is based on AI. So since early days, we have started with manufacturing. So we've been working with FANAC to make the machinery smarter. So we use AI to be able to adopt to manufacturing quickly, that you can do prediction. We have done visual inspection for defects in the manufacturing line. Then we move into a more complex situation. So in the factory, you have a very fixed line, that you see the same product going through. But then when you go in a more chaotic environment, like for example in the plants, in oil and gas plants, you have this very complex units that are probably using more than 1,000 sensors, and you want your AI to be smart enough to handle that data in real time and make a smart judgment to make that refinery either more sustainable or to increase the yield of that manufacturing. And those tend to be very critical, mission critical applications. So you cannot have your AI hallucinate and make mistakes. It needs to be very sure that you cannot break the system. So those are some of the characteristics that are very important for doing physical AI or for doing AI in the physical world. Then what we spent also a lot of time to not only do the macro scale of things, but we went all the way down to the atoms. So in the atomistic scale, you also need to understand how those atoms are behaving to be able to use that to create some new materials, so new battery, new catalysts, new CO2 capture materials. Those are all need not only language, but also understanding how the physical world actually is being used. So some of the challenges usually in doing physical AI, you have either data is not enough, so we have data scarcity, and you need to be smart on how you can use that in a very sophisticated way. You don't have enough compute, so it's running on the edge. It needs to be small models and using less energy. So those are some of the challenges that physical AI needs to solve. So we are quite familiar with this environment and how can you scope AI to be useful for the physical world. And then when you go to robotics, maybe in the next slide, we do have teams working with robots. So for example, our preferred robotics subsidiary, they have a robot called Kachaka. So this is the one you see on the bottom. And this is now the most used AMR in Japan. It has been growing very quickly. We have seen people in factories, in clinics, in logistics. They are using this robot to carry things around. So it's a very simple function, mobility, but very important. So it's also important for you to scope what the task or the use case that you want for your robot. Of course, we can go into humanoids and try to do all the tasks at once, but sometimes it's very good to have a specific task, but do it very, very precisely. So that's one of the applications. Then we moved into adding vision to this AMR robot. So we added this camera tower that you see on the right side. Those are yellow robots. And by having those walking around the store, we are able to build a digital twin of grocery stores, pharmacies, and those kind of places. So now you have a very detailed and real-time understanding of your store, so we can do a much smarter operation. And I have been doing AI for the last 12 years, and this is one of the applications that I saw robotics moving to mainstream. And mainly the big challenge was always the cost. You can make your robot as smart as possible, but then humans can do that a lot cheaper. Now we are at a stage where we are able to meet that price point, but also there is a big challenge that we have in Japan and gradually in globe, which is the labor shortages. So actually, even if you are able to do that cheaply, you cannot find people to hire to do a very good operation in your store. So by having these robots can help you design your operations to be more efficient, more stable. So the key ingredient that we have seen here is how can you design the context for your robotic applications. So you want to design your process and your operation with robotics in mind, not trying to just automate the same thing that humans are doing. So this was, I think, quite critical for us that moved the needle, that now we see customers are adopting more and more robotic solutions in Japan. So this is still pre-Gen AI work, so it does require a lot of hard kind of mutual understanding from the people who are in the physical world and then your robotic solution. But now maybe moving to the Gen AI discussion where, next slide please. So we have talked about how models are very good at doing language. So they are now doing your documents. We have agents across organizations. They are doing a lot of the processes and automating that. So language, I think it's moving very nicely. Now we're adding this vision modality. So you want your foundation models to also understand images better. And here our focus, because we want to bring this capability in the real world, we want our models to be able to run on the edge. So this is like a drone camera or maybe a security camera that you want to be able to run Gen AI, which is usually is very heavy compute. So our main focus was to see if we can make small models to do or to capture high capabilities that the models on the cloud are doing. So this was our attempt in the last few months, and we were able to create a vision version of our PLaMo series that is about 8 billion parameter that can perform better than much bigger models that we see either from China or from other models. So this is one of the topics when you are very focused on the use case. I think you can bring the models to be small and can deliver them close to the use case that you would work in. So we took this and we have worked with our some partners to see how far these models can be helpful. So in the next slide, there is just a sample of 2 use cases. One is a problem that we have been asked many times here in the industry to capture the know-how of the experts here in Japan. So we have an aging population and a lot of expertise is in their brain, and we want to capture that by using cameras. And before Gen AI, we were doing pulse estimation, object detection, a lot of kind of tasks to be able to do that. Now the generative models can understand the images and the videos much better, similar to what humans do. So we can do very high context understanding of the scene. So we see in the left side, we have a task analysis of workers. So this is a very common use case in manufacturing. You put a camera that can observe your employees to be able to detect if they missed any operation or if there is any step that is taking too much time you want to improve. So it gives you a lot of information about the details of how your people are doing the job. So we see the generative AI-based models are performing in much higher accuracy. On the right side, this is the usual anomaly detection. Anomaly is something that you have never seen before, so the model needs to understand things without having to train it. So these foundation models are able to detect some differences in, let's say, drone camera. So we have your drone fly over the plant, and it can detect if there is anything that should not be there. So this is another task that is very common in the industry. So what we're doing now is that we're trying to see how to bring those image-based models to the industry and make them useful, and to see how far we can push the limits is the way we are approaching this before going into humanoid and those more complicated tasks. So that's our current state of approaching the physical AI use cases.
Thank you so much. We understood how high performance a PLaMo VL has based on your instruction. So yeah, I believe that again here, Microsoft can be a quite important partner for this VL's implementation in the world of physical AI. So Nozaki-san, could you please introduce how Microsoft can support PLaMo VR's implementation in the world of physical AI?
Sure. But prior to that, ideally, I wish you guys also deploy the PLaMo BL into the Foundry too.
Definitely, it's coming for sure.
Yeah, so thank you for doing that. So then I think my perspective, this is a hybrid deployment is very essential for Japanese mission critical physical AI sites where latency is non-negotiable. This is, I think, definitely requires a real-time operation for sure. So it's called we have Azure Arc and Foundry Local. So we enable a hybrid infrastructure in Azure. So this is foundation we could provide it in our cloud networking. So you can land the PLaMo on your local GPU clusters while maintaining a consistent management plan through the Azure portal. So we have a capability for monitoring and then as looking at observability by Azure portal as well. So this is, I believe, it's an idea for air-gapped environments or low latency scenarios in manufacturing and healthcare. Then even probably for different industry. Then I think nowadays we require lots of real-time operation in the physical AI. It's a mandatory steps for doing this. And I think this is probably the one of the combination, good combination we could propose it. Then also we have a physical AI development reference architecture using Azure. So sorry for this busy slides, and we have a lot of diagram, but I'm not gonna go through all kind of steps. But so you can see the variety of the combination we support using multiple angle of the services or products in Azure.
Oh, thank you so much. I believe I love this reference architecture because we can understand how Microsoft is supporting the world of physical AI in the as a cloud platformer. That is very good architecture. So I believe that you have many other initiatives in Microsoft focuses on physical AI, right? So could you tell me more about your initiatives?
Sure. So, so at the Microsoft, we have been very focusing on the providing the series of opportunity for everybody who is interested in physical AI. Then, for example, if you look at the left side of the screen on top, then we have a AI Co-Innovation Lab. This is the Microsoft opened this Co-Innovation Lab in 2023. Then it's actually the very open forum. Then everybody can come, and then it's a free services. Then as if you submit the registration, then pass your share your the development, the goal. So then we can evaluate it, and you can come to the Kobe and then stay a week to do some POC. Then we have a bunch of opportunity to think about it, and AI, then particularly for physical AI as well. Then if you go to these places, you can see the bunch of physical AI, machine, and then demonstration in person, physically. So that's one. Then second one is that we opened 2024. We opened the Microsoft Research Asia Tokyo Lab. So it's the first time the research lab in Microsoft Foundation. Then we are now having a team over there. Then they're focusing on the embodied AI and the physical AI as part of their development. And then you can see this is a bunch of series of outcomes coming from them after 1.5 years of their research and development experiences. At the same time, then they also we recently announced the VLA model called the low alpha. That's the light, the bottom. So this is particularly for the physical AI model. Internally, we released through the Microsoft researchers. Then this is more on the focusing on the creating to the simulation of the physical movement. Then recent sample, I didn't show the pictures, but I think one of the good use cases using this model was using the robot in the data centers. Then, for example, data centers, we have like a very repeatable jobs in the maintaining all the hardware. It's like a heavy lifting for the very heavy the infrastructure instrument. And then also the bunch of network cables we have to maintain. And one of the example, it was the robot unplugging the network cable and then plugging the cable using then the physical AI robot. Then that kind of the sample we use this model called the low alpha model was the foundation of the VLL model. So something like this, and we have continued through the Microsoft researches, we have continued making some of the research objective for the physical and embodied AI. That's the focusing on the Tokyo office nowadays.
Thank you so much. So we understood that how Microsoft can support preferred networks not from the point of commercialization by a foundry, but also from the R&D collaboration. Yeah, that is very wonderful. So Karim-san, would you like to come to the Microsoft Lab and do some more wonderful projects together?
Yeah, definitely. This is exciting. I think one probably it's worth noting is that I think it's a testimony that the opportunity for physical AI and robotics in Japan and Japan to be leading the front in that domain, I think it's quite apparent having the R&D lab here in Tokyo and also in the Innovation Center in Kobe. And these use cases are actually being built in the frontier. So you actually need researchers to be very close to the industry and working together. So I personally think that for generative AI, the physical AI is one of the areas where Japan can lead the front. We have very, very strong robotics and industrial companies in Japan, and being able to build that in the frontier, I think is very exciting for us, and we would love to develop it in Japan and take it globally with Azure in the future, right, Mr. Nozaki-san? Thank you for having us.
Thank you so much. Thank you so much. Oh, so I understood that PLaMo's Azure deployment is just the start from our wonderful collaboration to the world of physical AI. So could you add some comments, Nozaki-san? Or could you just close this session and move on to the question?
Yeah, I just repeated. I'm really excited to having a PLaMo in the Azure Foundry. Then, as you know, nowadays there are so many options, and as I said, even the Microsoft, we provide 11,000 modules. The customer can choose whatever you like it. But so it's quite important. So to think about it as the Japanese company, as people, then how data, like Karim-san mentioned, how the data was stored, like high quality of data was based in their model, then probably you can see some of the differences by using this product. So I really look forward to see some of the good use case coming from the Japanese company using the PLaMo. It's really looking forward to it.
Yes, we're very excited to see what type of use cases that you will come up with. That is always a big inspiration for us, and it's a good motivation to see how PLaMo is being used by different customers in different use cases. So if you have anything interesting, reach out to us and use PLaMo on top of Azure. That would be my recommendation for today. Thank you for listening.
Thank you very much, everyone. Thank you. So please step down from the stage. Thank you very much. So we hope you enjoyed this session.